Hey everybody, welcome back from a spring break. I hope everybody had a nice, enjoyable quarantine while while you're on break. So yeah, let's get right back into it, guys. This is the last part of Unit 7, honestly. We're just going to take these rational functions that we've been working with, adding, subtracting, multiplying, and dividing, and now we're finally going to use them to solve. Okay, if you notice, look at this. It's equal to sign. Equal to sign tells us that it's a solving problem. So let's dive right in. The steps for success. It says factor everything that is factorable. We're going to have to do that. Find the least common denominator, which we've been doing. Multiply all terms by the least common denominator so that all denominators cancel. That's the new move that we're going to make. And then we solve and always check for extraneous solutions. So start with finding the least common denominator. I know it's been a while, but least common denominator always comes from combining the denominators. So 1 is 1 over 1. So we would combine all of these things. It would just be 7 times x. So 7x becomes the least common denominator. The new thing that happens in these, though, guys, is that we have to multiply everything by this 7x. So we multiply the first term by 7x. We multiply the second term by 7x, and we multiply the last term by 7x. The reason you have to do that is because you want the denominators to go away. So if we watch this, 7 would cancel with the 7 in the bottom, so we'd be left with 3x. X would cancel with x in the bottom there, so then we would be left with plus 8 times 7. And then at the end, 1 times 7x is just 7x. So then we're just going to solve from here, right? We can solve this equation. It's just 3 terms, two like terms, and we'll just solve for x. So subtract 3x to the other side. 8 times 7, that's going to give us 56, is equal to, what is that, 4x. And then divide by 4 from both sides, and that's going to give us, what, 14. X is equal to 14. And then we need to always check our solution. Okay, so then if we come back through here, just a real fast check, we would go 3 over 7 plus 8 over 14. Is that equal to 1? That's the question. So then we come through, so 3/7 is simplified. 8 over 14 would be 4 over 7. So 3/7 plus 4/7 is 7/7, so it looks like it works. So then 14 would be our answer for x, okay? And so that's how basically all of these are going to go, just like that. So let's take a look at this next one, guys. It says 3x over x plus 1 minus 5 over 2x equals 3 over 2x. So we always start least common denominator first. Okay, least common denominator, everything in the bottom. So x plus 1 shows up one time. So we have x plus 1. 2x shows up one time, so that's multiplied by 2x. And then there's another 2x here, but it's only 1 2x is the maximum time it shows up in the bottom, so we only need 1 2x in the least common denominator. And then we're going to go through this, right? So we multiply everything by the least common denominator, so that would be, let's just say multiply x plus 1 times 2x, multiply by x plus 1 times 2x, multiply by x plus 1 times 2x. Go through and cancel what cancels. X plus 1 cancels with x plus 1. 2x cancels with 2x. 2x cancels with 2x. So then we multiply everything that's left. So that would be 6x squared. This would be 5 times x plus 1. So that's going to be minus, because the minus drops down. And then it would be 5x plus 5. I put that in parentheses because this top part, right, this top part right here, is technically in parentheses. So then we just keep it in parentheses. And then we say it's equal to 3x plus 3. And then we're going to go through and we're going to solve this. Notice, quadratic. How do we solve a quadratic? I hope someone said set it equal to 0, because that's exactly what we got to do. So it would be 6x squared minus 5x minus 5 is equal to 3x plus 3. We subtract 3x and 3 from both sides. So we get 6x squared minus 8 x minus 8 equals 0. Hope this is going to factor out for us. Looks like we could pull a 2 out, so that gives us 3x squared minus 4x minus 4 is equal to 0. Okay, let's see if I can factor this. So it's going to be 2, 3x, and x plus and minus somewhere in there. And 4 is at the end. We need a 4 in the middle. Looks like -6, so minus 2 there, plus 2 here, because that would give us -6x, and this would give us positive 2x, and then 2 and -2 gives us -4. Yeah, so it looks like it works out just fine. Great news for us. So now that we have it factored, we can finally get the actual solved part of this, right? Because this is equal to 0. So then what you do is you just set all the factors equal to 0. So you'd set 3x plus 2 equals 0, x minus 2 equal to 0. So we say 3x plus 2 equals 0, x minus 2 is equal to 0. So that gives us, let's slide this one down, x is equal to 2, and then we'd also get x is equal to -2/3. Okay, checking if that's going to work, right? We always have to go back to the original function and make sure it works. So the things that you need to look for, guys, when you're plugging this stuff back in is things like dividing by 0, okay? Because that could show up sometimes. So those are the things to be careful for when we're checking those. You can also check these solutions with your graphing calculator or Desmos, whatever you have downloaded. Let's see. I'll pull up Desmos so I can show you how to check your answer here. Okay, Desmos open, Notability open. So to check your answers on here, what you would do is you would type in the left side of the equation in one line, and then you would type in the right side of the equation on the other line. You could also do this in your graphing calculators, which I highly suggest you practice for like taking a test or like when you get to pre-calculus and will be expected to plug these in. So what you would do is you would do 3x divided by x plus 1. And then you would say minus 5 divided by 2x. And then that's equal to 3 divided by 2x. And then what we have to look for is where do they cross. So we say it's going to cross at 2. So then let's go to 2. Yep, looks like there's a point right at 2. And then we also say it's going to cross at -2/3. So then we point there. Yep, and -0.667 would be -2/3. So it looks like both of those answers are good answers for us. So then we can box them in. Okay, and that's pretty much how you're going to do these questions, guys. So let's keep going. Number 3, least common denominator here for number 3. We have, it looks like just x minus 2 is the only thing in the denominator. So then we take all of these and we multiply them by x minus 2, multiplied by x minus 2, multiplied by x minus 2. Remember, it's always multiplied by least common denominator. Cross, cross, and then this is distributive. So that's 5x is equal to 10 plus 7x minus 14. And then again, we're just solving for x here, guys. So subtract off 7x from both sides. -2x equals 10 minus 14, -4. Divide by -2, and we get x is equal to +2. Notice what I just said we should watch out for. Plug in x equals to 2 right there, right? As soon as you plug that in, you get 5 over 2, and then 2 minus 2 is equal to 10 over 2 minus 2 plus 7. So then that's 10 over 0 equals 10 over 0 plus 7. Cannot do that, right? We can't divide by 0. So then this is an extraneous solution. And then because that was the only possible solution for that, it means then the proper answer for solving this problem would be that there is no solution. Sweet. So that gives us an example of what happens when we plug a number back in, it doesn't work. All right, number 4. Last one, right? Always going to be the hardest probably, but hopefully we can figure this one out. So let's take a look at number 4. Always want to factor. It looks like we can factor in this one. It's sometimes helpful to factor the top, so we might as well give it a shot. And then factoring the bottom as well. So if we factor the bottom, we can pull out x, so that would be x times 2x minus 3. And then actually, we're going to leave the top just as it is for now. Let's not factor it. Keep it as it is. Least common denominator then becomes 2x minus 3 from the first one, multiplied by x from the second one, and then the last one is x times 2x minus 3, which we already have. So we don't need to double down. So then we're just going to take this, we're going to multiply it by all of these things. So 2x minus 3 times x, 2x minus 3 times x, 2x minus 3 times x. Cancel, 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 cancel. So then we have 3x times x plus 1 times 2x minus 3 is equal to 6x squared plus x minus 18. That is what we're going to take and we're going to solve. So we come through this. That's going to give us 3x squared plus 2x squared. That's going to be plus 2x. That's going to be minus 3x. So negative x minus 3 is equal to 6x squared plus x minus 18. And then we have squareds up in here. Squareds tell us it's a quadratic, so it looks like we're going to have to set equal to 0. So 3x squared plus 2x squared is 5x squared minus x minus 3 equals 6x squared plus x minus 18. Set it equal to 0. I would keep your x squareds positive, so I'm going to subtract the 5x squared, add the x, and add the 3. 0 on the left side, x squared plus 2x minus 15. Hopefully that factors. X minus x plus looks like 5 and 3. So then x can be 3 and x can be 5. Let's see if either of those is extraneous, right? So we look back up here for an extraneous solution. It looks like we can plug them both in, okay? And then I'm just going to do the quick check of throwing it into Desmos real fast to see if it works. So then we're going to go 3x divided by 2x minus 3. Then we can say plus x plus 1. Didn't want to do that. Delete that first parenthesis. Plus parenthesis x plus 1 divided by x. That's equal to 6x squared plus x minus 18. All of that divided by 2x squared minus 3x. And then we look for all the times they cross over here, guys. Okay, so we're saying 3, so hopefully that's 3. Nice. So we got 3 right there. Oh, it's negative 5, isn't it? As you can see from my graph, negative 5 is the other solution that works. So then it looks like both of those are good answers. That's why it's always important to check, guys. Make sure they work. And it could tell you what the right answer is after you do the algebra. Okay, so let's keep moving on. Some word problems for these ones, guys. Okay, so it says Ben can rake a lawn and bag the leaves in 6 hours. Monica can rake the same lawn and bag the leaves in 4 hours. Working together, how long would it take them to rake the lawn and bag the leaves? So there's 2 types of word problems we're going to see. There's work problems, and then there's also these problems that are called rate problems. The rate problems are going to be down here on the second page. This one is a work problem. We're talking about raking a lawn. That would be a work or something to get done. So the equation for work problems is always going to be the job divided by the hours multiplied by x plus the job divided by hours multiplied by x gives us how many hours it takes to complete the job. No. Sorry. Equals the job that they get done, right? So x in all of these cases is the hours it takes to finish the job. Okay, so we read back through this. It says Ben can rake a lawn and bag the leaves in 6 hours. So it says he can do one job. He can rake the lawn once in 6 hours. We're going to multiply that by x. So this is rake one lawn. How long does it take him? 6 hours. We add that to how long does it take Monica to do it? So then Monica rakes the same lawn and bags the leaves in 4 hours. So she rakes one lawn, 4 hours, multiplied by x. Okay? The question is asking us, working together, how long would it take them to rake the lawn and bag the leaves? So how many jobs are they getting done? They're getting done one job, raking the lawn, right? If it said raking 2 lawns, then we would put a 2 here. Or if it said 3 lawns, we would put 3. Okay, things like that. So now we need to solve for this question. Many ways to go about it, but the easiest way, least common denominator, and then solve for x. Okay, so we say LCD, least common denominator. We have 6 and we have 4. The smallest number that both of those things go into, 12. So then we multiply everything by 12. That's going to give us 12 divided by 6 is 2x. 12 divided by 4 is 3x equals to 12. Right? Yeah, so then 5x is equal to 12. So then x is going to be equal to, what is that? 12 divided by 5, 2.4. 2.4 hours. Okay, so that's an acceptable answer. Okay, if you want to get kind of neat, you can make 0.4 hours into minutes, right? To do that, it would be 0.4 times 60 minutes. So if we did that, 0.4 times 60 gives us 24. So it would take 2 hours and 24 minutes. Okay, I'm going to pause the video here, and then I'll make a second video for the next page.